I want to take you through dynamic partitioning and dynamic system domains as our technology has been now for the past 5, 6 years. In fact, our static domains, which is what IBM expects to announce and is now promising, was available in 1993. Right? Dynamic domain is really the hard stuff, and that's what's going to take a couple of years to do. You know, you might think it takes a year, but that's because you haven't done it yet. When you start doing it, you know how hard it gets. So because every board in the system is connected to every other board, it is possible for a subset of the boards to team up and ignore all the rest and run a separate copy of operating environment on those 4 boards and be their own domain, in this case, domain 1 with the orange boards. Likewise, a different subset of boards can team up together and form their own domain, and that's domain 2 with the yellow boards. What is really cool is that you can take resources out of one and add it to the other while all the applications are running. And you can do that with a point and click or in an automated way through our automated dynamic reconfiguration. In this case, board 3 in the orange domain is taken out, it's deconfigured, and it's logically enabled and back into the yellow domain, just like that. And we're going to show you how that's done. And when you go with the Max CPU board, that stuff becomes instantaneous. So let me tell you how dynamic resource management is, as a critical part of total cost of ownership, is helped by dynamic system domains. If you look at how we compare with the IBM mainframe, you see one key component that we don't have that the mainframe has, and that's shared components between partitions. It is really hard to do that while maintaining fault isolation and security isolation. The only way mainframes have done it is through 15, 20 years of software development and complexity and inefficiency. Sun has done it a different way. We are the only company that provides a combination of hardware partitioning and software partitioning. And that's what allows us to get close to the mainframe on this kind of capability. That's what allows us to do dynamic control, fault isolation, security isolation, and a single management framework. Now, partitioning is all about how many different ways you can carve up a system. There are many ways to do that. We all do it in a different way. LPARs are one way. Workload management is another. Partitioning is the combination of hardware and software is what's required to accelerate the path towards mainframe class functionality. If you don't have it, you can't do it. Now, we talked about architecture. RAS is a critical part. If you want to reduce total cost of ownership, if you want to help data centers modernize and restructure their mainframe environments, you got to have reliability, availability, serviceability. With the Enterprise 10,000, when we announced it back in 1997, Sun took the first major step towards that kind of functionality, with features such as dynamic reconfiguration, alternate pathing, etc. With Sunfire 15K, we're introducing a host of new capabilities that absolutely narrows the gap. We're totally knocking on mainframe's door when it comes to reliability, availability, serviceability. So much so that we are able to claim now parity at the hardware level. This is an incredible feat. Now, I want to invite Renato Ribeiro, who runs the technical marketing group for the Sun 15K, and has been living and breathing this stuff, to take us through some of this capability. Welcome, Renato.
Thank you, Shaheen.
So what do we have to show today?
Thank you. So we're going to compare the RAS features of the 15K with the largest IBM server that runs Unix.
So this is the latest IBM high-end Unix server.
This is the IBM P680. This is the largest Unix system, AIX system that IBM provides today.
Excellent. Let's see what
So if you take a look inside the black boxes, they did something to us, Shaheen.
Oh, they do that every time.
Yeah. So let me take this and give it to you.
Let's see. This is really cool. All right. Well, this is an ad that we've been running. It says last year, 50 IBM mainframes met Darwin face-to-face, and naturally, they were not selected. Goodbye. So what this is referring to is the 50 mainframes that we have replaced just in the past 12 months. Now, not every customer is ready to go do that, but more and more of them are, and we're there to help them. Well, let's go on with the demo, Renato.
OK, so if you look inside the black box, you see that this machine was not designed for serviceability. All the critical components are hidden behind a solid steel plate.
So it takes like 10 minutes to unscrew the plate.
Yeah, just to get to the screws. In fact, IBM says there's a big label here that says, attention, permanent and costly damage will occur if during normal operation you take this thing out.
So you can't even touch this thing, let alone mix and match components.
You touch it, you break it.
So we're not going to spend 10 minutes unscrewing the
No,
plate.
we already did this on the other side. I'll ask the guys here to just change it, to rotate it. And, OK.
All right, so what do we have on this side here?
So here we have the critical components of the system. We have removed the steel plate. We have things like CPU, memory, etc., I/O.
So is there anything redundant in the system that you can take out without impacting applications?
No, there's nothing redundant there. So if
let's show what we're doing.
Yeah, so let's go to the demo. If you can see there up on the screen. What we're doing is we're streaming video out of 150K over there, and we're streaming video out of this IBM server. So while, if you see that video stopping, it's because the server stopped. If the video keeps on going, it's because the server is up and running.
So in practice, this could be any old application. It could be a mission-critical app. It could be SAP. It could be data warehousing. It could be whatnot.
Exactly.
All
so
right.
Because we don't have redundancy on these critical components, if I simulate the failure of any component here, you'll see that the server will fail.
So if you remove any board here, the entire system comes down.
Yeah. If, for instance, if I take a memory board and remove it, the system would just go down.
CPU board?
Yeah, if it fails, the system goes down.
How about, is there anything in a control board, something as simple as that?
Yeah, even the control board, the clock that contains the clock of the system, if that thing fails, you have the system to go down.
So we're talking about a $5 component that can bring down an entire mission-critical application.
Exactly.
Well, let's do that. We actually would be nice to see that happening.
So I'm going to reach in here. OK. So
well, that stopped.
Yep, that's
now, I claimed all sorts of redundancy on the other side. I imagine
Exactly.
that when we get there, we should be able to do a lot more.
Exactly. So let me show you how we do things on the 15K
Well, I
side.
hear all this thing about Regatta coming next week. Are they going to like up that by the time they
No,
get
they're
there?
not
Have you
going
guys
to,
looked at it?
I mean, we have 4 or 5 years advancement. I mean, they're 4 or 5 years ahead of them. They're not going to fix this redundancy until then. We don't have any indication
I think
of
if
that.
they remove the iron shield, that would be a pretty good first step for them.
Yeah,
to
I
do
think
that.
so.
All right, let's go
Let's
see
go
what we
over
do
there.
here.
So what we're going to do here is open the doors, and we're going to kind of do the same thing here with the 15K. So first of all, let's just take a look at the system and see how it looks different. I mean, all the engineering that goes into here to make it more serviceable, to make the components more accessible, to just make easy to pull components and do upgrades online, etc.
Well, let's start with the same simple component, the clock board, the control board. Let's remove that and
Okay,
see what
so
happens.
we want the application up there. So we're going to do the same thing we did on the other IBM system. We're going to remove the system controller that contains the clock. And if I just remove it, you see that
And it's
nothing
still
happens
running.
over there.
Can we do an I/O board?
We can do an I/O board. In fact, for I/O, I can either remove a hot swappable PCI card, or I can remove the whole I/O hub or I/O board.
So the whole I/O assembly, the whole I/O hub can come out.
Yes.
Well, okay, let's go for the big guy. Let's do a CPU memory board.
So we can do a CPU memory board. We can remove this 4 CPUs, so many gigabytes of memory.
And it's still running. And how long can we go doing this?
I can go, go on forever here.
I'd like to see us doing a few of
Okay,
that.
so let's just go on. I'll just go wide here.
All right, now we're going to let Renato go wild on this thing. But basically what you're looking at is the level of redundancy and availability that is just not possible anywhere else. I think, he's just going to go nuts doing the power supplies and the fans and the boards. And this is just this side of the machine. You can turn it around and repeat it on the other side, and this thing will still keep going.
Want me to go back?
I think we got the point, Renato. Thank you. That's great.
Okay, I can go on.
I think that's fine. That's
Okay,
great.
so I'll just put things back together.
So let's go back to the slide set, and let's see how this stacks up as you put it next to the competition. Let's go to the slide set that we have from the demo. What basically we're going to see is the ranking of what can be redundant in the system. I talked to you about system management and how we're knocking on mainframe's door on that front. When it comes to redundancy, there's a bunch of simple stuff that we did 8 years ago that IBM is beginning to do now in terms of power supplies and fans. Those are kind of hard to do, but they're mechanical, and they don't require the combination of hardware and software and robustness and scalability that makes it all possible. When it comes to hot swappable system boards, the system controller, the whole redundancy that exists on the center plane here, that's the kind of technology that really puts us heads and shoulders above IBM today, and above IBM next year, and above IBM the year after. All right. Now,